time constant and length constant are going to affect your conduction velocity, or how fast your action potential moves down the axon. But they're going to affect it in different ways.
So it affects the speed of the action potential, but in different ways?
Mm-hmm.
Okay.
So time constant, if you just like give a basic generic definition, is going to be how long it takes for the current to change time until you reach 2/3 of final value. But another way to think about it is time constant is how long it takes for something to depolarize or repolarize.
How long it takes something to depolarize or repolarize?
Right.
Okay.
Okay, so you have two components of the time constant, and that's going to be membrane resistance and membrane capacitance. Okay. So resistance is how easy it is for things to move across the membrane. If you have a high resistance, it's hard for it to move across the membrane. If you have a low resistance, it's really easy. With capacitance, that's the ability of something to store the charge up.
Ability to store the charge up.
Mm-hmm.
Okay.
Okay. So to find the time constant, you just multiply these together. So time constant equals, and I'm just going to abbreviate R times C.
Okay.
So if either of them goes up, you increase the time constant. The way that you normally look at this is when you're dealing with myelin, where that's the main application that I see.
Mm-hmm.
So when you have myelin, you have really high membrane resistance where the myelin is. But you have really low membrane resistance at the nodes of Ranvier. So that means that while you're in the myelin, it's impossible for the ions to go across the membrane. But while you're at the nodes of Ranvier, they go really, really fast. And so basically what you have, if this is your axon, it's going to travel fairly quickly through the myelin because it can't do anything. It's just going straight down the middle. But when it gets to these nodes, it's excited. It's got a chance to go and exchange, and so it's going to really quickly, and it's going to go. So when you talk about action potentials and saltatory conduction, that's when people say it jumps from node to node because there's no action within the myelin, just at the nodes.
Okay.
Okay, and then capacitance is the ability for something to store charge. And so this goes up with myelin because within these you can store the charge really well. It can't leak out. And so you have increased capacitance with myelin.
Myelin equals increased capacitance.
Mm-hmm.
Okay. And if you increase capacitance, then you increase your time constant.
Actually, just kidding.
Just kidding. I
Just
thought.
kidding. It says it decreases membrane capacitance. And increases resistance.